I am really thrilled to be here, by the way. What a gorgeous day, what a gorgeous location, and what a wonderful opportunity to celebrate all of the great things that are happening in the bio world, the bio space in Rhode Island. What I'm going to do for the next 15 to 20 minutes is try to set the stage of the moment that we are in as a country, as a world, and why the work that is happening in Rhode Island, why the work that's happening in the US is so extraordinarily important. And it really begins, in my mind, by understanding the era that we are in, the moment that we are in. And what do I mean by that? When the history of the 2010s, 2020s is written, it will be described undoubtedly as the era of biology, as the era of biological engineering. Now, these eras are always obvious in retrospect, but I think this one is obvious even though we are in it right now. Now, we've had these eras before. I would argue that in the 1890s and 1900s, we had the era of chemistry and engineering chemistry. We figured out how to engineer chemistry. Until then, we had spent decades, centuries studying chemistry, but we really never knew how to manipulate chemistry. And then in the 1890s and 1900s, you had Marie Curie and Ernest Rutherford, a guy named Fritz Haber, who won the Nobel Prize in chemistry, and they learned basically how to manipulate chemistry. And the first major manifestation of that was the use of chemical weapons in World War I. Now, my talk is going to get a little dark for the next 5 minutes. Hold on. It'll get sunnier, but we're just going to stay with me for 5 minutes. The 1920s and 1930s was the era of engineering physics, right? And we had all sorts of great scientists, Niels Bohr, who described the atom. We had Einstein. We had Heisenberg and the uncertainty principle, Max Planck, who talked about quantum physics. And it was an extraordinary period of learning about physics, understanding physics, and then ultimately manipulating physics or engineering physics. And that led to lots of great things, but it also led, in the 1940s, to the development of nuclear weapons. Then there's been about a 60-year hiatus. And the era of biology, in some ways you could argue, begins about 25 years ago with the reading of the Human Genome Project. But in my mind, that was still just reading. It was understanding. It was not manipulating. And the real era of biology begins about a decade or 15 years ago when we first learned how to manipulate biology, how to, instead of just reading biology, we learned how to edit biology and we learned how to write biology. And a few things have gone into that. You have people like Jennifer Doudna and the work on CRISPR, the ability to do synthetic biology. You heard about Caitlin Carrico and the work on mRNA vaccines. And these are going to be the Niels Bohr and Einsteins of our time when we go back and look at this era. The era of biological engineering is where we are now. And in my view, it is the most consequential of the three eras. There are three basic sciences, chemistry, physics, and biology. This is the last one where we have crossed the threshold. We now know how to manipulate, edit, engineer biology. And this era is going to be transformative. And it is going to have manifestations in three ways that we are going to feel for the next 20, 30, 50 years. The first is going to be on health. All of the incredible work, there's Vertex right there, all the work that is happening in this community, but really in communities across America, on building the biotech ecosystem really for health, cell therapy, gene therapy, but again, a lot of things that you know about. That is going to be one major manifestation of the biological age. But there are two more that I think are worth talking about. The second is going to be the impact on the economy. So we've been hearing a lot about manufacturing, right? Tariffs to bring manufacturing back, so maybe we can all start building cell phones here in the United States. I have no expertise on this. I have no idea if any of that is going to work. But I will say this. To me, the most exciting stuff in manufacturing is happening in biomanufacturing. And I think about a company like Manus, which is their headquarters are about 10 miles from here. So you all know stevia, right? Stevia, the sugar substitute that's in Splenda, comes from the stevia plant. And the way you usually make stevia is you get large amounts of plant. It's grown in South America. and you grind it down and you isolate the sugar, and it's a pretty significant production process. Manus took that process, the way the plant actually makes stevia, and then engineered bacteria to make stevia. And now, Manus has become the largest producer of stevia in the US, with a huge factory down in Georgia, actually, in Savannah, where bacteria are programmed to just kick out stevia all day. It's faster, it's cheaper, it's cleaner, and much of the stevia many of you might consume are being produced by bacteria today. That is biomanufacturing. That is a whole different way of thinking about manufacturing, and that's just for one chemical, and we're going to see that happen across the board in many, many things. Turns out the cell is a pretty powerful manufacturing engine, and if you learn how to harness the cell, you're going to be able to do a lot of manufacturing. So that's the second way we're going to see the manifestation: health, the economy in terms of biomanufacturing. And the third I've kind of alluded to, which I'm not going to spend as much time talking about, but I'm happy to in the Q&A, which is the impact on national security. Because I can assure you that if the first big manifestation of chemical engineering were chemical weapons, and the first manifestation of physics engineering were nuclear weapons, we are going to see the development, and we're not going to see, we are seeing the development of biological weapons that look unlike anything we have seen in the past. Again, it is that convergence of CRISPR and other tools like CRISPR, synthetic biology, and AI. Or as I like to say, we have the tools, we have the materials, and now we have the know-how. So those are the three big themes in my mind of the biology age: the impact on health, the impact on the economy, and the impact on national security. This is widely understood by senior leaders in Washington. Inside the Trump White House, it was certainly understood inside the Biden White House, and in Congress by Republicans and Democrats. The second thing that is understood by all the serious political leaders in Washington is right now this is a two-country race. That in these areas that are going to define our economy, are going to define whether America stays a wealthy country or becomes a poorer country, stays a healthy country or gets second in line on health, stays a secure country or has serious problems with national security, this is the era that's going to define it, and it is a two-country race right now. And that two-country race is, of course, us and China. Now, if I were giving this talk 2 years ago, and I've been very deeply involved in this with people, obviously, initially with the Biden administration, even now talking to folks in the Trump administration and working on these issues. If we were here 2 years ago, I would have said it's a neck-and-neck race. And we have a pretty good shot of staying up to speed and maybe even winning this race. It is not a neck-to-neck race anymore. We are now behind. Like, there's no question. No serious person out there questions that. And so we got to get our act together and start catching up. And by the way, if you're like, well, what's your evidence that they're getting ahead of us? If you look at the trajectory of what is happening, let's just talk about pharmaceuticals. 5 years ago, if you look at the big pharma, remember, big pharma talks a good game about innovation. Most of the innovation happens with biotech, and then big pharma steps in and licenses or buys those companies up. 5 years ago, big pharma's licensing and purchasing agreements, almost none of them included Chinese companies or Chinese products, because that's not where the innovation was. That's where the manufacturing was. In 2024, a third of all the things that big pharma licensed or bought were from Chinese companies. That is a scary trajectory over a four-year time period. So we are heading towards a point where bioinnovation, a lot more of it is going to be happening in China than it is going to be here. And I've got lots of other examples of how China is now pulling ahead. So what do? We got to catch up. And how do we catch up? So I want to talk a little bit about how we're going to catch up. I'm going to talk a little bit about what we need to do from the policy point of view in Washington, because I just told you that serious people inside the administration, serious people in Congress understand this challenge, and yet there are some incredibly self-destructive things that we are doing at the same time. Because the federal government is big and complicated, and sometimes the left hand doesn't know what the right hand is doing. So the strategy here to get ourselves back really requires focusing on three things. First, we got to have the talent pool. Last year in China, there were 90,000 STEM PhDs. In the United States, it was 40,000. Half of ours were given to students who were on visas. So the first thing we got to do is we got to build up our STEM PhD programs, and we got to stop the anti-immigration nonsense that is keeping, look, we all can agree on sealing the border, but stopping really, really smart students from around the world who want to come here, that is really destructive. I think about a German physicist who was a professor at MIT, Nobel laureate, named Wolfgang Ketterl. I'm sure I'm mispronouncing his last name. But won the Nobel Prize, was a professor at MIT. And every university in Germany was trying to recruit him back. And he was staying at MIT. And they gave him big money and lots of money for his lab. And a German newspaper called him up once and said, "Why will you not come back to your home country?" And he said, "Oh, the answer is simple. If I go back to Germany, I will have the best and brightest minds of Germany up and down the hall. And that would be great. But at MIT, I have the best and brightest minds of the world. And that's better." One of the things that has led America to lead in this area is that we get the best and brightest to show up at our universities, to show up at our research institutes. And it is, and look, this is not a partisan thing, but I have to say it because if we're going to be serious people, and instead of just rah-rahing, we're going to be great, we're going to solve all these problems, we are not going to solve these problems unless we deal with some underlying issues. One of them is we cannot have an immigration system that keeps the best and brightest out of our universities. It's incredibly self-destructive. So that is number one. We've got to fix our talent problem, and that means increasing the number of STEM slots. It means keeping our doors open to the best and brightest minds across the world, and keeping our community hospitable for those individuals. We cannot do this on our own. We just don't have the number of people, and we don't have the capability. The second is going to have to be around investments. The NIH budget is $48-ish billion. The administration has obviously put out a budget that would dramatically cut that. I think you have in Congress, again, serious people who understand how incredibly self-destructive that would be. This is not the time to sort of cut back on the basic funding. $48 billion is a good amount of money. If you think about how much of that goes to kind of the bio space, probably about a third to half of that. You already heard from Mark that 99.4% of our drugs started with NIH grants. China's investing, it's hard to know the exact number, but somewhere in the sort of $20 to $30 billion just in the biotech space. And if we decide we're going to be we're just going to put in a lot less money than that. Now, that is going to be a serious problem. So we have to figure out how to deal with the investment cuts. And in my mind, there are two or three things we got to do. One is, got to push back on federal cuts. Second is we got to think about new partnerships, new sources of funding. Now, in some places, cities and states are putting up money. That's happening in Rhode Island. That's happening in Massachusetts. But it's very hard to make up the kind of dollars that the federal government is doing. And then the third, and last but certainly not least, is we've got to build the ecosystems around this. And you've heard a bit about this from Mark. And I will say this is why I'm very excited about the Rhode Island Life Sciences Hub. We've got a great ecosystem here in eastern Massachusetts, but we have to have them in many places around the country. San Diego's got a burgeoning one. Rhode Island is a natural. It's a natural for two or three reasons. One of them is you got to have really strong political leadership. And I think we have that. We have that with our state leadership. We certainly have that with the mayor of Providence, who I know is here, who has just been, I think, an extraordinary leader. Doesn't get enough credit for what he's already accomplished and is going to be accomplishing a lot more. And then you have a bunch of universities. Of course, I'm at Brown, so I tend to talk about Brown first, but URI is an extraordinary place that has a lot of very good people, and goes from there. So I think Rhode Island is particularly well suited for this challenge, but it really is a challenge at this point. So I want to just finish up by saying, look, we are in serious times, and I generally have tended to believe, and I felt this during the pandemic, is that sort of sugarcoating things and saying things are great and they're going to be great and we're going to be great is fine, But we should also be very honest about the complexity of the challenges we have in front of us. I think we are entering the golden age of biology, not the nightmare age of biology, the golden age. We are going to cure a whole bunch of diseases that we couldn't even imagine curing. That's already starting to happen. We are going to transform our economies by taking what has been huge challenges in manufacturing and transforming them using biology as the underpinning for that work. And there is a lot of work to be done on the national security front that I and others have been very involved in. Happy to talk more about those things. But the truth is that we can keep our nation secure, and we can have our nation be resilient to future biological threats, whether they're man-made or natural. Those are all within our power. But we've got to stay focused on investment, building up our talent pool, playing to our strengths, and our strengths including being a very welcoming country that brings in the best and brightest from around the world. If we don't do those things, I think our future generations will look back and blame us for missing this golden opportunity. And there is no reason for that. And that's why I was very heartened to see all of you arrive here today, because I think you all have a role to play in that, whether you're an innovator who's actually out there doing the innovation, whether you're a policymaker enabling that innovation, whether you're an academic doing the work that needs to be done. Rhode Island, I think, is particularly well suited to help lead this effort, but it is going to have to pull all of us together in this. But if we do it, I think we can not just catch up, but we can have a very bright future for biology for Rhode Island and for America. So thank you very much for listening, and I'm happy to take questions.
So you and I spoke about this the other day a little bit. How do all of the people here be that ambassador for science and research? Obviously, you know, we're in a time period where science in the public is being questioned.
Yeah.
How can we be those ambassadors?
It's a great question, Mark, and let me start off by saying this is a really important challenge. You know, we have had this sort of agreement between the US government and our research universities and our academic medical centers that's sort of been implicit. They fund the research that they want to see funded. The universities do that research. It leads to huge gains in our economy, huge gains for health, and everybody's happy. Well, it turns out that the government is renegotiating that agreement. And I think we have failed, we in the academic world, and I will take as much responsibility as anybody, at explaining to Americans why this is important, what it is exactly that we do. This is not about university budgets being harmed. Nobody cares about university budgets. I mean, people in universities care about university budgets, but Americans don't. So we have to make the case to the firefighter and the teacher in Allentown, Pennsylvania, why does this stuff matter? And it matters because I have increasingly talked less about NIH budgets and university budgets, but about the fact that, 30 years ago, 40 years ago, a kid who got diagnosed with leukemia was going to die. It was a death sentence. No longer the case, right? That we are making incredible progress on cancer and cardiovascular disease and diabetes and all of that because of the agreement that the federal government has had with our research universities. And so this is not about NIH dollars and university budgets. This is about health of the American people and the things that they actually care about. And that's the case we have to make, Mark. And we have not done a good enough job. We have just assumed everybody understands it. And that's on us. And we have left ourselves vulnerable to a lot of people sharing a lot of nonsense. All of you have to be ambassadors. You all have to get out there and talk to your friends, family. I'll give you one quick 30-second story. My daughter, who's 20, pretty smart kid, says to me, "Hey, Dad, why is the federal government giving money to Harvard? Does the federal government really need, does Harvard really need federal dollars?" And I thought, she's 20, she's just finished her sophomore year in college. The fact that she's asking me that question means we have failed. The federal government isn't giving money to Harvard or to Brown or to Yale. The federal government wants to see research done on important topics like childhood cancer, and they put the money out for bid, and the best and brightest win those grants, and a lot of them are at Harvard and Brown and Yale and University of Texas and University of Alabama. And we have to remind people that this is work that the American people want done. And that's what universities are doing. And we have not made that case. And we got to make that case.
Thank you very much. One or two questions, Sarah.
Hi, so I'm Sarah Radcliffe from Narragansett. Thank you very much for your response to the previous question, and thank you for your leadership in that regard. I have a question about the university corporate interface and translational research.
Yeah.
So as the money is getting withdrawn from the government side, how do you see the relationship between universities and the private sector changing, if at all, and if so, how?
Yeah, it's a great question. And I would say two things. First, clearly, some universities are better at that than others. And I think all universities have to get smarter and better on this. That building those relationships between university and the private sector writ large, whether they're corporations, whether they're, it's just got to be much, much easier. There's way too much stickiness, way too much complexity in those relationships. I see that at Brown. Brown is working on it. But I think that needs to grow substantially. But let me be very clear on something. That corporations, private sector, isn't going to fund basic research. There's no value in it for them. There's no market for that. Because the problem with basic research is you don't know when it's going to pay off. You don't know if it's going to pay off. And companies just can't justify that. So the only people who can justify that are people who have the long-run vision for the health of the well-being of the American people, and that's supposed to be our government. That's why 99% of our drugs started with NIH grants, because you need to do that fundamental research. Now, I think there are ways in which some of that can be made cheaper with AI. I think there are opportunities for becoming more efficient in that space. So I am all in for universities doing a lot more with the private sector. But I don't want us to have this sense that that alone, I'm not suggesting you're saying that, that will somehow replace what the NIH is doing, because it can't.
I think we have time for one more question. Over here, ma'am.
Thank you so much. My name is Dr. Kamirata Polor. Work for a drug development organization, Radius Research. Anywho, fabulous talk. As a daughter of a healthcare worker who was an immigrant, I definitely appreciate your sentiments on needing to definitely consider talent outside of U.S. borders. I was curious about if there are conversations about the development of talent within the U.S. As you know, there have been cuts fundamentally to a lot of research programs and things of that nature. So I was just curious about that.
Yeah.
If that was.
No, look, two things. I mean, there is a global talent pool. And to go back to Wolfgang Ketterl's thing about being at German universities, you have the best and brightest of Germany, that was said about 20 years ago. That is also changing. So just to stick to the sort of China-US thing, China is getting much smarter about this. I mean, they have 1.4 billion people, so they got a pretty good talent pool to draw from. But they know that that alone isn't going to be enough. And so they are finding ways of attracting scientists from around the world. So we do have a very serious challenge, because our country of 330 million people is not going to be able to effectively compete. Now, that doesn't mean we don't need to do a lot better job with our own population. I think we absolutely do. And here, more programs in STEM training and biology training would be extraordinary. And so a lot of the cuts you're seeing from the current administration are to those programs. And let me be very clear about one thing that I think is important. This whole American government invests in these things, we build the training programs, has been deeply bipartisan. I have spent a lot of time up on the Hill in the last 4 months, and more time with Republicans than Democrats. This is not a partisan issue. And this sort of all these cuts to our development programs, to our training programs, it's driving Republicans crazy every bit as much as it's driving Democrats crazy. So let's just be very clear about this. This has not been partisan in the past. I have zero interest in turning it into a partisan issue, because that does not help America. But we have to get back to building training programs but also at the same time bringing in the best talents from around the world, because the size of the competition is enormous, and we cannot do this alone.
Dr. Jha, fabulous comments. Thank you so much.
Thanks, everybody.